Hi, myself Keshau, currently pursuing final year B Automobile Engineering at Kumaraguru College of Technology, Coimbatore. Thanks for Emertxe Technologies for providing me this internship opportunity. In this internship, I have learned about embedded systems. So, as the end of this internship, I need to complete a project. So, let we see the project presentation which I have done. So, the title of the project is Simulation of Washing Machine using PICSIMLAB. So, let me show you what are the key learnings which I have learnt in this embedded systems internship. Throughout this embedded systems internship, I have learned many concepts in embedded systems. Let me start with the basics of embedded C, where we'll be use the embedded C and what are the real-time examples of embedded C. And introduction to embedded systems, we have learned about what is embedded system and what are the core concepts in embedded systems and some of the types of embedded systems. And we have learned about the key difference between microcontrollers and microprocessor, as microcontrollers and microprocessors are one of the core component in embedded systems. Some of the core concepts of microcontroller, like what is microcontroller, what are the peripherals of the microcontroller, and some of the core concepts like gpio, timer, interrupt, and introduction to the project and the requirements of the project, like what we are going to implement at the end of the internship, and implementation of the project by using MPLAB IDE and PICSIMLAB. So we have learned about how we can use this MPLAB IDE for programming and PICSIMLAB tool for the simulation of project. In embedded C, I have learned about the usage of embedded C, where the embedded C is used, and the key difference between what is C programming and embedded C. And I have learned about the characteristics of the embedded C, how the embedded C is performing, and some of the code format of embedded C, how we need to write the structure program. And I have learned about the structure of embedded C. Like first we will have an header file, then we need to define the macros, and next global variables, next to this main function, and inside the function we will write the programs. And data types and the number systems. In data types, I have learned about float, double, integer, boolean, character, and strings. And in number systems, I have learned about binary, hexadecimal, decimal, octal number systems, and the conversion of binary to hexadecimal, hexadecimal to binary, decimal to binary, decimal to hexadecimal. These are the conversions which I have learned. And some of the conditional constructions, if else, and loops like for loop, while loop. And I have learned about call by value and call by reference. And I have learned about pointers. Pointers are one of the important concept in embedded C, where we will store the address of the variable or a system. So let us see about what is an embedded systems. Embedded system is nothing but it's a combination of hardware and software which is designed to perform a specific task. Embedded system is one of the important in real world. So it is programmed by using embedded C. The application of embedded systems in this world is huge. Say for example, in real time examples, we have used a washing machine which consisted of a controller unit to perform the washing operations, and we have an automotive electronic control units which is used to control the movement of the vehicle, and air conditioning systems which will be used in the home applications, as well as refrigerators is also used for home applications. So let us see about the categories of embedded systems. There are mainly four categories which are available in the embedded systems. They are standalone embedded systems, real-time embedded systems, networked embedded systems, mobile embedded systems. So let us see about the standalone embedded systems. Standalone embedded systems is nothing but it can able to perform alone without the dependency of any systems. In standalone embedded systems, we have an slave standalone embedded systems where it will get the instructions from another system and it will perform. And we have an independent standalone system where it will selfly able to control the systems. For independent standalone systems, the Tesla car is the examples. And let us see about the real time embedded systems. Real time embedded systems are designed to take action within a specific amount of time, which is a time bound systems. There are mainly three types in this real time systems. They are hard real time, where we need to deadly follow the deadline. And the examples of hard real time systems are airbag ECU system, where we need to deploy the airbag within around 40 milliseconds. And we have an firm real time where the property loss will be maintained. And we have an soft real time systems. In soft real time systems, the deadline is not more constrained. And we have a networked embedded systems. The network embedded systems, the multiple devices are connected together to perform a specific task. So the example of network embedded system is a home automation system, and mobile embedded system where we have an separate embedded system for a specific application, say for example our mobile phone. So let us see about the core components of embedded systems. The processor is nothing but it's a central processing unit which is used to perform some of the operations which we have mentioned in the software. Memories are one of the key component in embedded systems where we will store our programs for its execution. In microcontrollers, the program is stored in memories. In memory, we have RAM and ROM. RAM is nothing but the random access memory, or else which is we called as a data memory, which is a temporary memory, whereas ROM, read-only memory, is a permanent memory. In microcontrollers, mainly we have used flash memory and EEPROM, where the flash memory is used to store the program files and EEPROM is used to store the other data. And next we have an timers. Timers are one of the important concept in embedded systems, which is used to produce some clock signals. And we have an input output devices where we connect with the microcontroller to perform some of the tasks. And we have an communication interfaces, say for example UART, SPI, I2C, CAN. So these are the communication interfaces we can able to use with embedded systems. And the power supply is one of the key component where it is used to power the microcontroller. Only if we power the microcontroller will starts work, else the microcontroller or an embedded systems will not perform. So power supply is one of the important component in embedded systems. So let us see about the key differences between microcontroller and microprocessor. Microcontroller is a specialized form of microprocessor, where microcontroller is consisted of the microprocessor as a processing unit, and we have a microprocessor which is designed for the general purpose. Microcontroller is used to perform a particular task, whereas microprocessor is used to perform a certain task. The power consumption of microcontroller is low. The microprocessor power consumption is high. It contains RAM, ROM, CPU and timers as a single chip, whereas microprocessor we need to combine the timer, controllers and microchips as an external peripheral. The hardware architecture is followed in microcontroller, whereas von Neumann architecture is followed in microprocessor. The examples of microcontrollers are PIC16, Atmega, MSP430, STM32, ESP32 controllers. The examples of microprocessor are 8085 microprocessor. We have an Intel microprocessor. So these are the ARM microprocessor. So these are the examples of microprocessor. So let us see about the board which I have learned in this internship. So the board which I have learned in this internship is PIC Genesis board. The controller which is available in this PIC Genesis board is PIC16F877A Microcontroller. The operating frequency of this board is 20 MHz. The operating frequency is provided by the special circuit called an oscillator circuit, where the oscillator circuit is used to generate this pulses. From pulses we have an operating frequency. So by this operating frequency the controller is working. So the flash program memory is of 368 bytes. We have an EEPROM data memory is of 256 bytes. There are mainly 15 interrupts available in this microcontroller board. The I/O ports are A, B, C, D and E. We have 3 timer modules and 2 pulse width generation modules. The pulse width modulation is a technique where we use it to control the motors. So it has various components like CLCD, which is used as an output to display something. We have an fan, tactile switches for the switch inputs, and we have an buzzers as an output, LEDs, ADC analog to digital converter, and we have an RS-232 for the serial communication. Let us see about the project requirements. Our goal is to simulate a real-time washing machine using PICSIMLAB by using MPLABX IDE. The controller which we have used in this project is PIC16F877A Microcontroller. The software which we have used in this project are MPLABX IDE, PICSIMLAB and XE8 compiler. The compiler is a special tool which will convert our program into the machine code, as microcontroller only knows zeros and ones. So the compiler is used to convert the program into machine code. So MPLABX IDE is one of the important IDE where we use to program the controller. It was developed by the Microchip Technologies itself. It is used to program and development purposes in embedded systems. The version which we have used for our project is version 6.25. And we have on PICSIMLAB. PICSIMLAB is a free software or a simulation tool where we can use various microcontroller boards available, which is an open source. We can able to simulate widely used microcontroller boards such as PIC, Arduino, STM32, ESP32, etc. So let us see the block diagram of our project. We have a microcontroller. On the right side we have an inputs. On the left side we have an inputs. On the right side we have an display or as output. So let us see about the input side. We have a switch 5 to power on the washing machine, switch 6 to pause or stop the program, switch 4 is used for the navigation purpose, and switch 1 is used for the door status indication. On the right hand side we have an display used to display the washing status of the washing machine, and we have an buzzer to indicate the thing that the washing program has been completed, and motor which is used to replica the washing machine, which is as a motor. To replica, we have used a fan in this system. So let us see about what are the components which I have used. So number one is the tactile switches. Tactile switches, these are the switches which will be in on mode only when the switches is pressed. Here the RB3 is used as the switch for navigation for scrolling between the options. The RB4 switch 5 is used to powering the washing machine, and it is also used for the continue the process. And RB5 switch 6 is used to stop and pause the ongoing program. The RB0 is used as the switch to indicate a door status of the washing machine. And we have an CLCD. The CLCD in washing machine is used to displaying the current status of machine. It is also used to show various options and to navigate through the options by using the switches. It also shows the time which is remaining to finish the program, and also shows the washing mode. Say for example, now it is in wash mode or rinse mode or spin mode. And we have an buzzer. Buzzer is one of the crucial component which we have used in this project. See, the buzzer in washing machine is used to keep the track of the washing cycle. The buzzer alarm will blow once the door is opened, or when the program is completed. The door opening, the simulation is done in the RB0 button. So when we press the RB0, it indicates that the door is opened. So the buzzer will be ring. It also activates for the 3 seconds when the washing is completed successfully. In this project, I have used the PICSIMLAB 9.1 version. The 9.3 version is not supporting for me. In 9.3 version, the buzzer ringing sound will be here. But in this thing, I does not have a buzzer in operation as I am using PICSIMLAB 9.1. So fan. The fan in this project is used to represent the working of the washing machine. When we set the program, the motor will be rotated in this fan to indicate that the washing machine is working. The spin of the motor is starts only when the washing mode is selected and continues till the end of the washing cycle. The motor stops when we press the switch 1, as we mentioned that it is used to replica of the door opening condition. So when the switch 1 is pressed, the motor gets stopped, and when switch 1 is released, again it will continue its operation. So let us see about the project demonstration. So this is the MPLabX IDE where I will created the program for the washing machine. So this is the main.c file, and this is the program where I has written the main logics of this washing machine program. So let us deep dive into our project. So this is the PICSIMLAB IDE, and we have used PIC Genesis board. The controller is PIC16F877A. The operating frequency of this controller is 20 megahertz. So we have set it here. Now let me reset the circuit. Okay. Now let me press key 5 to power on the washing machine. So this is the key 5. Key 0 or switch 0, switch 1, switch 2, switch 3, switch 4, switch 5, switch 6. So let me press switch 5. Okay. Now I am pressing the switch 5 RB4 to powering on the washing machine. The powering on display is displayed. and we have an 12 washing mode in this program. To navigate between the washing programs, we need to press switch 4. Now it's changed to heavy, delegates, whites, stain wash, eco curtains, woolens, bed sheets. Now I am select bed sheets as my program. Now I am going to long press the switch 4 or RB3. Okay, now it is changed to water level screen. Now I am going to navigate this water level screen by using switch 4 RB3. Okay, we have around 5 washing modes. Sorry, 5 water level modes. We have an max. 1 minute. Let me increase the brightness. Okay. Now let me select the max mode by pressing the switch 4. Long press. Okay, now it is asking switch, press switch or 5 to start or stop. Now let me press the switch 6 so that it will move. I need to change my program. So I need to press the switch 6. Okay. Now it is going to washing program. Now let me navigate through the, I'm going to use heavy. Now I'm long pressing the switch 4. And as a water level, I'm going to choose high. Okay, now I'm long pressing the switch 4. Okay, now it is asking press switch 5 to start or stop. Now let me press switch 5 to start my program. Okay, now it's showing program heavy and the program gets started. The timer is running. The timer is running. By using the timer, I have started to decrement the process. Now let me press switch 1 RB0 to show the door is open indicator. Door is open. Please close the door message is displayed. And the buzzer is ringing. As I mentioned, I am using the PICSIMLAB 9.1 version. We cannot able to hear the buzzer sound. Now the fan is also stopped. Now let me release this switch 1 to continue the program. Okay, now the program is continuing. Now the mode is in washing mode. So let me pause the program by pressing the switch 6. Okay, the program gets paused. Now let me resume by using switch 5. Okay, now it is in wash mode. So next it will going to change into rinse mode. Now I am going to again pause the program by press the switch 6, and now I am going to continue the program. Now I am going to press the switch 1 so that the door is open indication will be displayed. Okay, now we have around 20 seconds. So as washing machine is considered of around 40 minutes to 1 hour. For the simulation purpose, I have used this timing as an seconds thing and minutes. Now it is in spin mode. After finishing this, the program completed take your clothes display will be displayed. Okay, the program completed, remove clothes will displayed for a few seconds. After that, it will move to again to the washing program screen. Now it is moved to the washing program screen. So that's it about the washing machine project. As washing machine is one of the crucial component which we have used in daily our lifetime. So let us see about the conclusion. Our washing machine simulation project by using this PICSIMLAB microcontroller board demonstrate not only the practical applications of embedded systems in household application, but it also showcases the efficiency of the microcontroller based designs in a real world scenario. The programming of the microcontroller board can be very creative to develop the advanced machines using microcontroller and also plays a vital role in the development of technology. So once again, I am thanking Emertxe Technologies for providing me this opportunity. So thank you.